Welcome back to the Firebase I/O video series. I'm Morgan from the Firestore team, and I'm here today to talk you through how to write complex multi-stage queries using Firestore. Whether you're building an app the old-fashioned way or having an agent build it for you, you'll need some kind of database to store and serve the data your app needs to function. In today's fast-moving agentic world, you'll also want your database to have powerful, flexible querying abilities for building new features quickly and expressively. That's where Firestore comes in. Firestore is Firebase's flagship NoSQL database, providing automatic scaling, 5 nines of SLA-backed availability, MongoDB compatibility, offline caching via client SDKs, and real-time data sync. Full-text search, geospatial queries, joins, and data manipulation are new features as of Cloud Next this year, and they are our most requested features in the history of Firestore, so they're worth talking about in more detail. Let's jump straight in. Full-text search, as its name implies, gives users the ability to search documents using familiar keyword patterns. Full-text search uses a different query processing method, which relies on text indexes that tokenize your document data. When a user performs a full-text search, we apply our own search models to expand the query to more fully match the user intent, and match it to the tokens in text indexes. The results are then scored, and each relevant document is returned with an appended search score, where a higher score means a better match. This also means that search query results can be large, so when you use search queries, you should remember to limit or paginate your results. Unlike vector search, full-text search doesn't require vectorizing your document data or your query, and it ranks results based on text matching rather than vector distance. So if you're making an e-commerce app, full-text search is more suited for the search bar to let a user find products, and vector search would be better for recommending similar products once the user opens a particular product page. So what can you do with full-text search? Search lets you query in a familiar term or phrase format, natively matching synonyms and variations like spelling localizations. You can negate or combine search criteria within a search query, and you can also combine search queries across multiple fields. You can even combine search queries with other traditional filter queries. In the second part of this video, I'll show you a sample application that uses full-text search. But first, let's take a look at our other most requested feature, joins, which in Firestore are implemented as subqueries. Subqueries are queries that allow you to combine the results of another query to the documents of your original query. Subqueries are powerful. For example, you can run a query per document in the collection, which you could then add as a map field to effectively join two documents fields together. But you can also do a lot more with subqueries. For example, you can run entire aggregations inside the subquery. Again, we'll break this down in more detail with an example. All of this is possible due to the new Firestore Enterprise edition, which introduces a brand new advanced query engine. Firestore Enterprise edition has an entirely new category of queries called pipeline operations, which are queries that allow for the chaining of complex stages, including operations like unnesting array fields, splitting documents, truncating or adding fields, and complex aggregations that allow for aggregating multiple fields in a single query. Now that we have all these shiny new features, let's see what they look like in an app. Here we have an app used to store, share, and generate recipes. We've added some social features so users can save and review recipes written by other users. The data model looks like this. We have a collection of recipes with each document containing some recipe text, ingredients, author information, and user-generated tags. For our social features, we have a collection of saves and a collection of reviews, with reviews containing a rating value and both reviews and saves containing the ID of the user who created the document and the recipe the document refers to. We need some kind of discoverability to pair with these social features so users can find the recipes they're looking for. Let's build a filter menu with Firestore's new queries. In this menu, we'll use a singular Firestore pipeline and conditionally add stages depending on what search terms or filters the user chooses. First, let's write some basic sorts and filters. These are queries you'll be familiar with if you've used Firestore in the past. Simple equality or ordered inequality matches on a single document field. If you want to learn more about these, we just released an updated query explainer video that you can watch here. Now we have our basic sorts and filters in place, allowing for simple stuff like exact name matching and array contains. Let's write some pipeline exclusive filters. We've gotten pretty far with field and tag matching, but we're still missing some basic inequality filters and sorts, like sorting by rating or by most likes. In order to add those, we can use a subquery. Ordinarily, adding an inequality filter is really easy because Firestore supports simple inequality matching, like those filters we wrote earlier. But the values we're trying to match don't actually exist in the database. We're sorting by average rating or the total number of likes. But if you recall the data model we showed at the beginning, the database stores individual ratings and the number of likes isn't stored in a field at all. That's why a subquery is necessary in this case if you don't want to store an average. The value we need to sort by is computed in the subquery and then passed to the filter. Here's what that looks like. Within the pipeline, we create 2 additional pipelines, one for aggregating likes and one for aggregating the average rating. Then, we add the resulting values into 2 new fields on the parent query's recipe document. The resulting document will look like this. Note that these newly added fields won't persist unless you explicitly write them back to the database. Of course, using a subquery instead of just storing an average rating or total likes field makes your writes simpler and cheaper at the expense of more costly reads. If you need faster reads and don't mind slower writes, you can always store a pre-computed aggregate value and keep it correctly updated via transactions. Finally, let's add search. In our query, all we have to do is pass the search term to Firestore, have Firestore generate a search score, and then sort by search score, and we're done. Our search query can be prepended to the rest of the filters we've built, and they all play nicely together. No limits, no query not supported errors. If you've been watching carefully, you may notice I haven't actually shown any of the sort code for the fields we added. If you want to take a look at them and play around with this sample more, you can check it out on GitHub. That's all for today. If you want to learn more about Firestore Enterprise Edition, check out our docs and getting started instructions in the link below, or look at the Firestore Query video series. If you've heard enough about Firestore, continue watching the Firebase I/O video series to learn more about other parts of Firebase.